Right now, the only treatment is surgical treatment. There has been surgical intervention. It's still surgery, so we're not really moving. We're moving also not. ET procedure, cauterize a hole. I don't know if it's in the ventricle or if it's in what's called the process. Way out using this shunt that has such a high malfunction rate, infection rate, but that also comes with its issues because it's a cauterized hole that can get infected, that can close up, and only certain individuals are able to get this procedure because you have to have a certain type of hydrocephalus, quote unquote. For example, I am not a candidate for the ETV because of the complexity of my hydrocephalus. Maybe if I was born in 2024 developing hydrocephalus, I may have been a candidate, but by the time they had developed this device or procedure, I was, quote unquote, too far gone. My hydrocephalus was too far gone and too progressed to be able to be treated with anything but a shunt. We are making improvements in terms of things we can add to the shunt. There's a current neurosurgeon that we fund from Boston Children's Hospital, and he has developed this device, and he calls it the airbag. So basically it would be an additional mechanism that would be added to this shunt that would basically, under the supervision of your physician, you would be able to pump this device, and it would be able to blow out if there's a blockage in the shunt, which is great, wonderful, and it's coming. We've actually funded it. We funded this project from Dr. Madison since it was a drawing on a piece of paper. He brought it to one of our PHF meetings prior to me joining the PHF. And he said, this is my idea. I want to make this device so that we can lengthen the lifespan of the shunt, which is fantastic, because maybe if this device was developed back in '98, maybe I would have only had 12 surgeries, not 23. And we're also now looking at how is hydrocephalus occurring? Why are these babies getting hydrocephalus? And that's what Dr. Littman's lab, which is the lab that I'll be, hopefully, fingers crossed, employed by, she looks at why are they getting hydrocephalus? How are they getting hydrocephalus? What mechanisms are causing this to happen? So she's trying to understand it before it happens. And to try to give a brief explanation of my senior thesis, we were looking at how a brain bleed, which is very common in premature infants, can affect these cells that make it possible for signals to be sent to and from the brain. The cells are called oligodendrocytes. I don't know, for somebody who said I wouldn't walk, talk, see, or hear, now I'm saying all these words that I don't know.
Is hydrocephalus something that only happens to kids?
No.
Can it occur at all stages in life?
Anybody and anyone can necessarily get hydrocephalus. So there's hydrocephalus that is in utero. You can develop it from a tumor, an infection like I did. But we also are now seeing, let me read this statistic. Since 2000, over 370,000 U.S. service members have sustained traumatic brain injuries, which have led to hydrocephalus. So now our servicemen and women are also coming home with this life-altering condition And then there's also a condition.
Sports, like
And-
football and stuff, if you hit your head just the right way, you could cause a brain bleed or something that could hemorrhage that then causes this hydrocephalus. So it can more or less.
And then you also have what's called normal pressure hydrocephalus, which happens in older individuals. And a lot of the time it's diagnosed as Alzheimer's or dementia because it mimics the same symptoms. And if they catch it quick enough, they can get treated and go back to living a normal life. So it can affect anybody and anyone.
All the methods, avenues you described, it's all a secondary effect of something else. In your case, it was the effect of this.
For the most part, I don't know, I'm not sure in utero if, in the event of a brain bleed, there's a, 20 or 30%. I don't really, I guess I should have written down all of my statistics. We are looking, you know what? I don't know exactly that question. In utero, so if you develop hydrocephalus after in utero, it's because of something else. But right now, we're trying to unpack how are you developing it to begin with if you would develop it in utero. So that is a question that we're still unpacking. Is how are they developing it in utero? Why? Why are they developing it in utero? Yes.
Have they looked at any genetic kind of links, or
So
are
there-
they finding any predispositions to that?
So there is what's called X-linked hydrocephalus. So there is a genetic component in some cases, but not in all in utero cases. It's very complex, and I think that's one of the main reasons why we haven't made so very much quote unquote progress. Is because there's so many ways of getting hydrocephalus. There's so many ways you can have post-infectious hydrocephalus, you can have post-brain bleed hydrocephalus. There's so many ways of developing hydrocephalus. Understanding the mechanisms is crucial, and the brain is still such a mystery that yes, I think we're getting close to better treatment, especially with Dr. Matson's airbag. I think we're getting closer to better treatment, but I don't think we're anywhere near a cure. And that is the main issue, is that we're quite far, in my opinion, we're quite far here. And that's why I set out with the foundation, and because of the foundation, set out to conduct my own research and pursue a career in research so that the next generation of individuals don't have to endure all that I endured. Yes.
So hydrocephalus is just the condition of having water or pressure on the brain
Yeah.
from a variety of reasons.
Mm-hmm.
So is that really, so the valve relieves that pressure. So is it more important, like it's very complex to try to figure out what's causing all of them. So is there an issue within the valve itself that you feel that, or is there research going on for that you're really more invested in, or finding the reason for? I'm asking your personal question.
My personal, I love the direction that Dr. Linton's lab has pursued in terms of figuring out the mechanisms from the get-go. She's looking at proteins, the changes in proteins, the changes in the composition of the cerebrospinal fluid. She's looking at it from this tiny point of view, which is what I find fascinating. And that, at this point, I think the most important important direction at this point would be better treatment. However, the long term is figuring out how the heck do we stop it before it happens.
So I guess so you.
Did I not answer your
No,
question?
you did.
Okay.
But I'm asking follow-up is that for your case in particular, you have continual hydrocephaly that has to always be, and the shunt is helping this to continually drain. Is that the case for most, once it starts to happen? Does the body just keep on doing it?
For the most case, once you're shunted, you
Yeah.
become shunt dependent, and
Yeah.
for most cases, you cannot be unshunted. There are very rare cases. We have an individual that's part of PHF that he was having horrible issues. They decided, they did some tests, and they found out that he doesn't necessarily need his shunt. And,
I mean, it's a case question. You just, well, I'm thinking about it from an engineering point of view.
yes.
If you got this, why does your brain keep making this extra fluid?
So it's not that they're making extra fluid, it's that the body has a block. Hydrocephalus occurs when there's a blockage of this normal pathway. So this fluid is always in your body, and it's necessary, because if you didn't have this fluid, you couldn't walk around because your brain wouldn't have any cushion. It's basically a cushion. This fluid's a cushion for your brain. However, in hydrocephalus, because you're continuously making it, and it cycles through your body. I think you make a pint a day. So a pint a day circles through your body.
So it's not that the brain is making too much.
So basically, hydrocephalus
Okay, you're good.
is, so all of our bodies are making this CHF, cerebral spinal fluid. And it's going through your brain, and it's going through your ventricles and out, your down and around, and it's moving around. So all of us have that drainage system that's draining it through your body and stuff, where in